All right, today, this morning or afternoon, depending on where you're at, we're going to talk about the topic of simplifying decimals and comparing decimals. So there's two topics here, simplifying decimals and then comparing decimals. Now we've worked with decimals a little bit so far. Let's take a look at the decimal 3.2. Now there's some things that we've talked about with decimals. For example, one thing is that most of us would read this as 3.2. Now the proper way to read this would be to, with any decimal, ask yourself what place the far right digit is in. And if you remember, we go tenths, hundreds, thousands, 10,000s, and so on. Going to the left, ones, tens, hundreds. So the 2 is in the tenths place. And I would read that as 3 and 2 tenths. And that would be the proper way to say it. Now, what does 3 and 2 tenths mean? Well, I could write that as a mixed number. So 3 and 2 tenths means 3 and 2 tenths, like that. So I could write that decimal as a mixed number. Remember, whenever there's a number in front or to the left of the decimal point, it represents a mixed number. If there were not a number in front of that, I would just have 2 tenths, like so. Now, what else have we talked about? And I'm going to change this back to the 3 and 2 tenths. I'll make it blue just so we know that it's the same number. Now, if we were talking about dollars and cents, would it make sense that I would leave it written as 3.2? No, because dollars and cents, we need to at least go through the hundredths place. So I'd add a 0 to the end of it. So really, 3.2 and 3.20 mean exactly the same thing. When you have a 0 at the end of a decimal, really it doesn't have any value. So in some cases, we could use 3.2. In other cases, like using money, we'd have to have 3.20, or in other words, $3.20. Let's take a look at some examples. All right, in example 1, it wants us to write each of these in simplified form. So what we're doing here is we're asking ourselves, are there any unneeded zeros at the ends of the decimal? So in A, notice I have 2 zeros at the end. Well, this means exactly the same thing as 0.05. I don't need those zeros at the end. So again, I'm emphasizing that any zeros at the end of a decimal or to the right, they really don't have hold any value. So 0.05 is the same thing as 0.0500. Now in B, I don't need those. So 50.00 or maybe $50 is exactly the same thing as 50 or $50 if we were talking about money. In C, I don't need that 0 at the end. This would mean the same thing as 1.25. And finally, in D, it means the same thing as just 4. So 4.000 means exactly the same thing as 4. Zeros at the end of a decimal have no value. Now let's take a look at example 2. Now notice I have some blue circles in these because what I want you to do here is I want you to compare them with less than, greater than, or equal. So let's take a look at E. Now the best way to compare these is to make sure you have the same amount of decimal places on each side. So notice here I have 2 places to the right of the decimal. So I'm going to add a 0 to the end here so that I have 2 here. Now let's compare them. Let's see, I have a 2. Well, first of all, I'm going to make sure we're consistent on this. All right, let's compare them. So compare our zeros. Well, they're the same. I can't compare them. Go to the next digit. Here I have a 2. Here I have a 1. 2 is bigger. So 0.2 is greater than 0.15. Let's do the same thing here. Now, here I have 1 place to the right. Here I have 2. I'm going to add a 0 to the end to make it equal. Now, let's start. Here I have 12. Here I just have 1 automatically. 12.5 is greater than 1.25. And that should make sense, right? If you think of this as $12.50 compared to $1.25, certainly $12.50 is bigger. All right, for G, let's make sure we have 3 places to the right of the decimal in each of these. Now let's compare them. Let's see, 0, 0, can't compare them. 0 compared to 1. 0 is smaller, right, than 1, so it's less than. 0.012 is less than 0.12. Right, in H, 3 places here to the right of the decimal, I'm going to add a 0. Now let's compare them. So I have a 0 and a 0. Here, 3 compared to 0. 3 is bigger automatically. 0.31 is greater. All right, over on the side, I'm comparing 0.4 to 0.40. Let's see, 2 places to the right. Let's add a 0, so I have 2. What do you notice? They're the same. They're equal. All right, last example, example 3. What I want you to do is write these decimals from least to greatest. Pretty much the same philosophy. Now, what's the most amount of places to the right of the decimal? 3, right? 3. So I want to make sure I have 3 in each of them, and then I can compare them easily. All right? Now all of them have 3. Now, let's compare the first number. So 0, and I'm going to change that. 0, a 0, a 0, and a 0. I can't compare them, right? Let's go to the next digit. And I'll put this in blue. Okay, 1, 1, 0, 2. 0 is smallest. This is the smallest one. So 0.015 is the smallest, all right? Now, what's the biggest then? Well, these were 1s, right? This was a 2. So my biggest automatically is 0.2 or 0.200. Now, there's a tie. There's a tie between these. I got to figure out which one of these is biggest and which one's smallest to fit in between here. So let's go to the next digit. 2 compared to 2. I can't compare them. Go to the third digit. And that's why we added a 0. 0 compared to 5. 0 is smaller. So my next one would be 0.12 and then 0.125. And I've put those in order from smallest to largest. So our topic today was called Simplifying Decimals and Comparing Decimals.